growth since 1900, when the automobile started, 1908, something around that. So it has grown up exponentially across the world. And this is a forecasting from which is about 100 million vehicle, 100,000 million vehicle rather. And EVs are expanding. If you see the bottom portion of that, that is the EV numbers are rising. So by 2030, you expect about 30% or 40% vehicle will be EV. In India, it is slightly different story, and the projection is basically till 2040 that will be expanding exponentially. But primarily the green portion is two-wheeler. So India is still lagging behind growth in four-wheeler, especially four-wheeler, because two-wheeler, three-wheeler are going anyway. So Indian economy is driven by two-wheeler, three-wheeler growth. If you talk about cars, four-wheeler rather. So India is driven again by two-wheeler. So in last year, in globally 3 million vehicles were made electrical vehicle, but India made only 48,000. That is about 50,000 vehicles of that time. So it's 1.6% of electrical vehicle market globally. And this is how the technological transition took place in automobile industry. Till 1939, there was models which were running steam vehicles were there. Then in 20th century, early 20th century, IC engine came in and it ruled for almost 100 years. Then in early this 20th century, late 20th century, hybrid electrical vehicles started appearing, hybrid vehicles started appearing, fuel cell vehicles started appearing, and now future is for connected autonomous vehicle, which is electrical vehicle, but is connected to internet and IoT kind of a thing, which self-driving cars we talk about that kind of thing. It's far away, but when many companies are working on fully autonomous cars. They are working on a contained environment, not on public roads as of now. So this is how transition has taken place. So over the time, the vehicles become safer, they become reliable, they become affordable, efficient, and they are technology driven. Initially, it was a horse cart they were fitted with the engine. So in the future times to come, the three things will happen. One is the way the cars are made, and the companies which make the car, they will change drastically, because legacy car makers will go away. Tesla is a company, you must have heard the name. It is a Silicon Valley company, but it has started making cars. Last automobile company, which if you refer as a pure automobile company, it was Chrysler, which happened about 70 years back. Leave aside this Toyota and all those kind of things, but in America, it was last automobile company was Chrysler, which was born from zero level. So the cars that are built, how they are built, who will build, and who will buy, everything is going to change now in times to come. And they will depend on the green cars, convenient car, affordable car, safe car, and connected cars. The five things which should happen in times to come. And when you say connected car, so the technology called V2X, vehicle to everything, connected car. And there's again a technology R2X. So road will also become smart, so road to X, road will connect to everything, to car and everything else. So these are some of the companies which are working on EVs and CAVs, or connected autonomous vehicle. So you can find certain legacy makers into it, you can find certain new companies, even Apple is working on it, Microsoft is working, you can find Honda, Mercedes, many companies, General Motors, they are legacy companies. But Ola Electric is a new company, you must have heard about it. Nissan is legacy company, Toyota is legacy company, but Intel is a software company which is working on the car. In China, Continental is in fact the tire making company, which is now moving into car making. So more than 54, 55 companies, 50 companies are working on electrical vehicle. And this is similar to what happened in early 1900 when IC engine came in. I don't know how many of you read the books, but in early 1900 in US, there were 300 odd companies which were making IC engine cars. Slowly they merged into three cars, General Motors, Ford and Chrysler. So companies took over, they merged, and then they finally the three big they called, they became three legacy companies. But the same thing is happening in electrical vehicle nowadays. So we covered these 5 points which we saw: green, convenient, affordable, safe, and connected cars. To talk about green, why we are talking about green cars is uh, IC engine vehicle, they emit lot of they create lot of emission, and we staying in Delhi, you know about it last month, what was the condition. So greenhouse gases and all those conditions happen. So out of total energy consumption of India, it is not India globally, 16.2% is consumed by transport sector, and that literally it moves in the city, around the city, because it is not a stationary kind, it's not powerhouse, it is not a stationary kind of thing. So it affects the environment of city. So that is bothering people, and that's why people are shifting to EVs. So everybody is concerned, consumers are concerned, regulators are concerned, government is concerned. So this is one green car issue. This is how the global emissions have gone up. So the cars came somewhere in 1920 when they started picking up the numbers, and that's how the emission started increasing. And this has caused the worry to the people. Now coming to convenient part of it, the convenience, automobile has given a lot of movement, freedom of movement to people and all those things. That's everybody is aware of that. But with convenience over the time, the vehicles have become more comfortable. So that is a lot of things got added. So I think you know about all those things. You're driving, young generation knows about it. We have seen it coming on the way. When I joined the company, 82. That time nothing was there. We had Ambassador and we had Fiat. So there was nothing. None of these things were there in that car. So these things are there for convenience of people who are driving the car. And over the time, the cars have also become affordable. Now, why do we find so many cars on the road? Because people have buying capacity, but cars have also, the cost has come down. Now, how the cost has come down, you can understand from these three figures. When Henry Ford introduced Model T in 1908, it was taking 540 minutes to make a car. 540 minutes is roughly, say, more than 8 hours. Now, in 1913, he introduced interchangeability of parts. From that, the time has come down from 514 to 230 minutes, 2.3 minutes. And then he introduced conveyor belts. The time had come down to 1.19 minutes per car. And now Maruti makes in 60 seconds a car. Per 60 seconds, one car comes out of the line. Globally, about 1.3 million people die in road accident, which is probably more than how many people died in Corona. So this is some data of India, taken out from ministry data. So 1995, the market opened, right? So till 1995, the deaths were very low. You can see there are 200 numbers and all those kind of things. But when the market opened, number went up, and this is how the deaths have gone, accidents and deaths have gone up. Earlier it was 183 deaths per year on an average, and they were leading to about 31,000 deaths per year in India. But after the market opened up, the numbers have, the automobile markets opened up, the number of accidents had gone up to 4,74,000 on an average per year, and 1,38,000 deaths per year are happening in India on the road accidents. So it is up by 150%. And globally, India stands at number 6. That is 16.6 deaths per 100K population. So to make cars safe, it was not there, we are getting it done outside, but I think October 23, Mr. Gadkari had introduced this kind of a safety test. You must have Bharat and CAP kind of a thing. You do the crash testing and all those kind of things. And also the cars, when you make a car, you make it safe. So you do many things in there. You have airbags, you have ABS, you have stability control, you have seat belt, you have a number of things which have been built up over the time to make it much safer. Currently, the government is making the seat belt in the rear 3 seats. Initially it was front 2 seats, then it came 2 rear seats, now they're talking about 3 rear seats, 5 passengers. Now the next part is, next evolution of automobile is connected vehicles, whatever we call it, but it is going to come in next, when the new lifetime will come. So I call it V2X, which is a common term, but R2X is my terminology, which I have written in many articles also. So connected cars are basically, let me see. So this is how connected car works actually. So you have a number of sensors into it, which connects the data, collects the road data, gets connected to satellite. Then it takes a decision of how should it move. It reads the signal of the road. It reads the people moving around, not people, the objects moving around it, and then it takes a decision. So with this, now it comes to the main thing: what are future technologies of which are going to make impact on the automobile manufacturing? So one is 3D printing manufacturing, composite materials is second, modularization of automobile. Currently we make on assembly line, I don't know how many have seen automobile manufacturing, but it is an assembly line process. Then unibody casting of body shell, and also coating. And again IoT and biometrics are there into that. Photo you must have heard, that I'll see when it comes to that. So coming to 3D printing and newest composite material, it is 3D printing, you have heard about it, right? Anybody knows about it now? So 3D printing is very common word nowadays. You make buildings, you have small components made. So, but in US they made a car also. And it's called Stratty, and it's a 50 parts instead of 30,000 parts which are normally used in a car. So it has only 50 parts. This is something, it looks like this. So this makes it faster, this makes it much safer, much cheaper, and much convenient. Composite materials, aluminum is already used in the cars, but then you have graphite, you have HSS and magnesium and all those kind of materials which are going to increase when you start making cars, to make them lighter, to make them safer, to reduce the weight so that mileage goes up. This is a modularization of automobile manufacturing is a thing which is known from ages, but it's Tesla which has started using it, and now Toyota is also following it. Sorry, no, this one not. That is a die casting. So this is a modulation of automobile manufacturing. There is a company called REE in Israel. What it has done, it has made a vehicle, it is wheel rather, which is the first one. It contains everything. It is a drive, it is a brake, it is steering, everything is into one wheel. And you add 4 wheels and becomes a vehicle, it's become a car. You add 2 wheels, it becomes a scooter. And in the center you have a battery pack. So you increase the length, you see the last one. You have a different chassis. You have a 4-wheel, again you expand it, it becomes a truck. You add 2 more wheels, it becomes a 6-truck vehicle. And you have to only integrate each 6 wheels together and you coordinate. So it is software part of it. You just integrate the software part of it. This is the one which is known from ages. This is a method of making a car. You must have seen a toy car which is made. Pull karte hain jisko. So that is made by this method. And this Tesla has commercialized it for Model S. And now Toyota is following it up. So what they do, they use giga presses to make, to die cast the whole car, not whole car. Now they are doing the part of the car, but the plan is to make the full car by die casting. So this is something like this. This is a car shell. So if you see the main part of it, these 2 parts, front and rear, they have about 70-80 sheet metal components which are welded together. What Tesla has done, they have die casted both the parts together. So now they are 2 pieces of metal. So the effort goes out, the speed goes up, car becomes more safer because we have lesser number of parts into it. This is one of the drawing which I could get on the net. This is final version of them when Tesla plans to make full car body in one go. So one shell, one car. And the assembly becomes much cheaper. Initially, it is a conveyor line. Now, the current method is to make conveyor line and then keep assembling the vehicle. In gigapress, you make three parts: front, rear, and center. Center is battery. So you make rear part, front part, three parts to assemble, put the roof, put the door, and car is gone. So it is much faster to make. You can change the model much faster. The cars are much safer. That's it. Now ADAS, you have heard about ADAS, something on that? You can stop anywhere in between. You have something to ask. ADAS, you have heard anything? We have many cars in India which serve with ADAS features. Okay. This is the advanced driver assistance system. Mahindra has it, Tata's have it, MG has it. I think many other cars, the high-end cars anyway have it actually. But mid-range car you have, so Tata's have, Mahindra, MG, probably Hyundai also has it. Kia also, some features are there. So that is to increase safety, and certain decision makings are left to the car. So suppose you are reversing the vehicle, so there is a camera and there is a screen and there is an alarm, so that is part of ADAS. Like in MG car, there is a mirror, there is a blinker, so if something approaches you from side and you are not able to see it, the light start blinking. So it tells you that there is something is there which you are not able to see. So that is part of ADAS. ADAS, there are different levels. 1, 2, 3, 4, 5 levels. So currently we have level 3 are available in India. 4th and 5th are not there, and that's why when we talk about level 5, it is connected vehicle. So on which Google is working, many companies are working on that. Even Tesla was working on that, but it could not, till now, they have not worked out it. So level 4, there will not be any driver, there will not be any steering. You sit in the car, you feed on the map, and it takes you there, depending on road condition and what. So it is still on trial basis. And I have written an article on this also, so you can, if you want, you can Google it. So level 4 is a bit lower, which steering is there, but you need to hold the steering after some time. So you can't just leave it. There is an alarm system in which it will keep on popping, so that you need to hold the steering. So these 4 and 5 are not in India, but not India, even globally it is not available right now. So 4 and 5 are currently lab based. IoT, biometric sensing, photo, this is last point. So if we talk about IoT, again, they are more applicable to connected vehicles. So for CAVs, we talk about CAVs, connected autonomous vehicle. Then you have to identify what is moving in front of you, what is in your side, what is in rear. So there is a lot of IT related analysis. You have to capture the thing and then analyze what is there in front of you. Child, a grown-up man, an old man, an animal, a cycle wala, whatever. Whosoever is there, you have to do a lot of statistics, data analysis, and then give a command to the vehicle. So computer vision is that part of that. Then you have to identify relative position of those people in front of the car or surrounding the car. So you have the electrical vehicle moving on the road, so you make road smart so that vehicle keep charging through induction when they are moving on the road. So they are again a part of future technology. Then there are somebody talked about vehicle in motion, weighing in motion rather. So now we see a lot of weighing scale on the road where the truck goes and then they measure. So you put the weighing sensor on the road, vehicle moves in and then it gets weighed up. So a lot of time gets saved. I don't know how many of you, but then lot of energy, lot of time, and lot of fuel gets wasted when the trucks wait for weighing of the thing. Not here, you don't see in the common thing, but you go to port, you go to mining, you go to any other places where the movement is taking place. So this kind of smart roads they help you in reducing the time. Again, this is we discussed about it. Then also when there is an autonomous vehicle, then it has to analyze the road condition, weather condition. how the road, how the braking will take place, how long will it take to stop the vehicle in case of emergency. So it has to analyze the road condition also. On the same road, night condition will be different, day condition will be different, rainy season condition will be different. So it has to read the condition and then take a decision. So that is again a challenge from IoT point of view. Again, animal hazard, different height of animal, all those things have to identify. So with this IoT, you can do other things also like fleet management, automotive maintenance. Like automatically it gives signal to the dealer that my vehicle is due for maintenance, something has gone wrong in the vehicle. So either he can repair it online through photo, or it can send somebody, or you can ask the vehicle to come in depending on the condition of the vehicle. This I we know in photo, you have connected cars, you have internet, you have other things connected to the vehicle. Then there is biometric sensing which is coming up, in which sensors are built into the steering wheel seats to know the condition of the driver. Suppose driver is driving is not well or is feeling sleepy, so the vehicle should give an alarm. So there are sensors into the steering wheel. Suppose his hands are sweaty or his hands are shaking, so it will give a signal that something is not right, you should not drive the vehicle. So that thing is already in the high-end cars is already there. Sensors are there in the seat also. So to know whether it's comfortable, not comfortable, there is some problem in his sitting posture. So they keep sensing it and then keep upgrading the database to tell that something is not right with the driver. Photo is firmware over the air. I think people, if you are using Ola, you know they keep a lot of photos, right? And vehicles keep coming, and then you keep upgrading the software part of it. But there is a challenge here. Probably government has to look into it. I'm not sure whether they are looking. Photo is only should be allowed for non-functional software, not a functional software. Because functional software, if you change it, it can cause an accident. Suppose today you give one feature to the vehicle for certain kind of a braking, and then you later on you change it. That is not allowed because that will not get passed through government regulation. So there is some limitation in giving photo. Okay, this is challenge. Electrical vehicles are coming. I think everybody knows about it, but electrical vehicle has their own challenges. They have high voltage system into it, so safety becomes a problem. Operation, maintenance, and during rainy times, the high voltage system really creates a problem. So technicians, whatever, I don't know that makes sense here, but service where there is a challenge that technicians have to be trained for that kind of a work. Currently, people open the IC engine vehicle anywhere near the road with a spanner and everything. You can't do it electrical vehicle because that may cause a serious accident because there is high battery and there is a high voltage system, high energy system. Then batteries have a runaway issue because you must have seen a lot of fires happening in the electrical scooter and cars. So batteries have a thermal runaway feature problem. If you're not controlling it properly, it can cause a fire. So these are all kind of things probably not related to you, but this. Now, coming to service sector challenge, in IC engine there are about 20,000 moving parts. Electrical vehicle it is hardly 20. So service sector when you talk about, you have to explain to the people. This is difference between the two models, two version of vehicles. So IC engine is a complex vehicle, but it is a simple mechanical device, electromechanical. But electrical vehicle is a very simple device. There is only one motor, one battery, and there is a controller. But it becomes a very complex electrical, electronics, IoT, software part of thing that becomes a complex thing. So you need a very specialized person to train for working on that vehicle. That is a challenge related to servicing and manufacturing. And we talk about software part of it. I don't know that it makes sense for you, but then I thought these are languages which are required in electrical vehicle sphere. The MATLAB is one, Python is one, Simulink is one, C++ is one. These are languages which are required to work on BMS or other electrical vehicle control system, Linux. And then finally, people need to build automotive culture which covers basically driving sensibility, electrical vehicle हो गया, smart and safe charging of EVs, the smart road with smart traffic signages, the smart parking, and automotive recycling. I have written an article on all of them, so you can Google it. Now, where ASPC comes in? That's probably the question you must be thinking about it. So, there is a great framework policy of Government of India which came in 2022, and it talks about certain credit scores for any skill you acquire. I have not seen it because we have passed through that phase. So, probably there is a credit score for every skill you do, every training you do. There is a credit score to your bucket, and that adds to your value, right? Correct me if I'm wrong. So these are some of the things you have spent number of years, number of classrooms training, number of physical trainings, and then the competency builds upon that. So that the government has defined about 1,200 hours of training per year, which leads to about 40 credits score. In a year, you can achieve that. Now, basically, the training model has to be approved by somebody. The government approves it, like ACC, one agency which gets the training model approved by government and gives to you for learning. So these are some of the key points of that policy. I'm not a policy maker, so I just wrote it down. So these are three pillars of this policy, in which I think all three, the ACC comes in the picture. They coordinate with the schools from 5th class to 12th class there is session, then graduation there is a different level, and then there is a skilled part of it. So all three covered by ACC. So ACC developed certain modules of 60 hours, right? 60 hours, which gives 2 credits to you, and they are to different fields. Design safety, which we talked about, additive manufacturing, 3D printing, automation robotics, CAD/CAM, CAE, cyber security is one, smart manufacturing is another one, data science, IIoT, electrical vehicle technology, battery swapping. Again, battery swapping is a different chapter, we can cover some time later. Flex fuel is another area in which all these technologies have been developed by ASCC, and people can get trained into that. And this is not engineering part of it. I think this is part of how do you sell it, how do you handle customers, how do you deal with the customer when they come with a complaint. All those things is part of management skill. And this all again what ASCC does it, awareness model of automobile. Then they set up centers for training. Then they train the trainers kind of a module. Then the course development is there. Then they make industry with it. You want to go to any auto industry or they supply second tier supplier, first tier supplier, so they will arrange it. Then they do assessment, they give certification, and they help you in placing you to auto sector. Probably yes, auto sector. Then they try to put you in that place. Okay, you can go to dealer's place, or you go to marketing section in some company based on your qualification, based on your learnings. And this is what a brief background of organization is there. This is one of the first skill council of India. There I think 30-40 skill councils working, but ASCC was the first one. It started sometime in 2011 and under NSCC. And ACMA, SIAM, FADA are part of supporting them. Three ministries are supporting to them: Ministry of Heavy Industry, Ministry of Skill Development, Enterprise Entrepreneurship, and Ministry of Road Transport. They are supporting them. These are vision and mission of, as you can see on the net also.
So more forward in the next 10 years. So they are picturing that. That's why I'm talking about 4.0 to direct 6.0.
India is still not at 4.0, right? So we are still serving in 4.0.
We are not able to bridge the gap for the requirement in 4.0 still.
But
So we are talking about 6.0, which is far away.
Yeah, but the question is basically when you talk about 5.0, it is more of a IT driven. IT, IoT kind of IoT and IoT kind of thing. So you have cobots working in the shop floor, but the skill set will get changed, right? Industry 1, if you know, again you read my article on that, I written on 5.0 also. So it was manual skill. Initially when I started, it was manual, Industry 1.0, whatever you call it. So 2, 3, 4, 5. 5 is more of a, becomes a automatic kind of thing. Humans are not working, or humans are working in collaboration with the robots. So you have cobot and robot working together. But you can't avoid human being working on the shop floor. You can't avoid, you can't make it zero. Certain cases, certain processes you can do it, but not all the processes. Right? So the skill set will get shifted. Where you have like span, tightening a span and all those things, those will shifted to the IT kind of a profile. Industrial automation, you have programming, you have other kind of skill which will you lead when you go for 5.0, 6.0. Right? Then if you talk about selling and marketing kind of thing, you need different approach in that. You can't just say, because this is a good looking car or good, a good kind of finish, but then tell an IT part of it. How does it behave? How will it react when it is a connected vehicle or what autonomous vehicles? Some kind of reaction happen when it is moving on the road. So those things have, the skill set will get changed.
So talking about the safety and regulations, so until unless your car or commercial vehicle is not certified by ARAI and compliance regulatory, but if you can see some of the heavy vehicle players, Tom and Tata also, are bringing their vehicles on the roads.
You can't bring on the road.
So in the Tata Nexon, the major problem happened in the internal battery BMS system. But still, and another question arises that the companies are not actually telling me what is the actual range.
Two, 3 points. You can't bring a vehicle without RI or ICAT certified on the road. Right? That is for sure. It's something.
Manipulation is happening in that also. So manipulation.
No. It cannot happen. At least a vehicle cannot happen. Auto industry doesn't work that way. You cannot bring any vehicle on road till be certified by ICAT or RI. Right? Company will get, government will close the company. That is for sure. Even after certification, there are challenges. Especially in EV, there are challenges. I was telling in the morning that the BMS which you're talking about, I am into BMS, I make BMS. No, 99% of BMS are China made. Now what do we do with that? It is not under covered and frame scheme. So just import it, put in the car. Tata kicks for the bar. Tata, I have about in 15 years, I know they will not do it. But most of the companies, they buy it from China, fit in the car, and that whatever you see in fire and all those, this is because of BMS only. Lithium ion batteries are, if you use second grade battery, there is a problem.